Hi, good afternoon, everyone. I believe my voice is audible to all the participants. Welcome, everyone, for our session on machine learning. In the previous session, we have done a couple of stuff where you all introduced with Dataiku. Along with, we have been having discussions on Python programming for implementations of data science and machine learning. So in our today's session, what we will be doing, we will be covering the machine learning part, where you will get to know that how using the current data set, we can make machine learning models with different equations, how we can compare them with accuracy and other metrics, which are very important in order to identify which model is perfect. So we are going to identify all of that. And finally, we are going to have comparisons with the actual data which is available and the model predictions. So we are going to create the plots so that you can actually identify how the actual data and the predicted data looks like, what are the differences, and how we can ensure the model which has been generated is a good model or not. So all that stuff we are going to do. Further, we can also integrate that application with a website, and we can deploy that model on AWS so that you can actually make your analysis ready for production. Then you can evaluate the security considerations, where you can check how the commands have been executing by a backend programming language and how it connects with Python. All that stuff you can do so that you can actually export your machine learning into a product, and that product can be used by people in the world. So all that stuff we will be doing in today's session. So let's go for it. I'm sharing my screen with all the participants, and I believe everybody is ready with the stuff. Now here. So what we will be doing, as you all can quickly observe, first you have to open your account on Dataiku, which we will be using. We have started working on house price prediction project just to give you a complete understanding about how everything is done, as well as we have one more project, that is segmenting telecom customers, understanding the churns and scoring the new customers. So we are going to have that information also. Along with that, I have also shared the data set for Talking Data by Talking Data company from Kaggle. So you can actually perform analysis on that also. Okay, so there will be a couple of data sets which you will be implementing and identifying the information. Now, so currently the first project which we have been doing is the house price project. Let's go for the project. Once we click on open, you can actually go to flow, and over the flow, you can identify what has been available with you. And one more thing which I would like to share with all of you, the Trello part, where under interns group 7, we are maintaining all the resources for this program, RGPV machine learning workshop. I'm sharing the link again for this Trello card so that those who might have missed, they will get access to this. So here is the Trello card where all the resources are maintained, the resources of the script and the data sets, whatever we have been using, everything is available over here. Now, first, I would like to again quickly open the Python machine learning document for all of you, just to give you a quick look again that where we are currently standing on the knowledge discovery process. Just confirm me on chat if my voice is audible properly to everyone. I believe my voice is audible. Just confirm me on chat so that I will be comfortably continue. Now here. So what next you will be having? So we have got this document where you have already understood that machine learning is a very important part of artificial intelligence, and machine learning helps us decide how AI works. Then we have these 4 stages which we generally have to implement. A machine learning engineer has to implement. He actually tries to identify what happened in data, why did it happen, what will happen in future, and how do we make the best happen. So today we will be working towards last 2 segments of our analysis, where we will be identifying the machine learning, predictive modeling, where we will identify what will happen in future, and we will compare multiple algorithms so as to identify which algorithm is the best algorithm which we can use in order to perform the prediction. Okay, so that is the optimization part also we will be doing, and we will be checking various accuracies which is available. So what will happen and how do you make the best happen, both the parts you will be implementing. Now, if you go down a little, here here, these are the three important building blocks of machine learning: the knowledge discovery process, cross-industrial standard process for data mining, and sample, explore, modify, model analysis, SAMA. So we have actually discussed all the three models, and you all are clear with the models. And currently, this is the stages which we are following for analysis. We have actually done the part of selection, pre-processing, transformation up till now. And today we will be working towards data mining, interpretation, and evaluation. In the previous session, we have done certain discussions on interpretations and evaluations where we have plotted certain graphs about the existing data. But now in the next stage, what we will be doing, we will be comparing the existing data with the predicted data, so that we will be able to identify, is our equation, the mathematical equation which we have identified after mining, is it capable of calculating the exact values or not? So if it is capable of identifying the right values, if it is highly accurate, then we can use that mathematical equation to integrate with our web application or mobile application. So that we will be doing it. Now let's go for it. So under this part, let us just first go to our flow data IKU, where we had the data set available, and now we will be implementing the data mining part. In order to do this, you can select your prepared data set, right click on your data set, and you can go to lab. Once you click on lab, you will have multiple options available over here, and these multiple options give you various ways to prepare the data and build the models. You can actually generate the models quickly by selecting some of the common models with respect to the outcome data. Then you have various options for auditing, principal component analysis, correlation analysis, which we have already done with Dataiku as well as Python in the previous sessions. So anybody who's watching the video for the first time can refer to the previous 5 sessions which we have organized. These 5 sessions are available on our website hackveda.in/121, where you can access all the resources. All the students, those who have the accounts available, they can log into their account, get access to mobile users design course, mobile users data analysis course, and within that you will be having all these videos. Okay. Now let's see. So we'll quickly proceed from here to prepare data and build the models. And we will be naming our analysis as analyze housing data set prepared. Let's click on create. Once we click on create, you will be having your data set, which is already prepared. It is already in numbers, and you already know how we actually converted all these variables into numbers. Using the concepts of pre-processing and transformation, we have converted all of them into numbers, and we have actually converted them into a common scale between 0 to 1, so that the data is analysis ready, and we can use this data set for processing, for implementations of multiple equations. And once we are done with implementations of the equations, we can actually use that equation in order to integrate that with a web application or a mobile application. Now, we have also explored the charts part yesterday, where I have actually shown you that you can actually select the line plots and the bar plots, where you can select your dependent variable, you can put it under the y-axis, you can select your independent variables, you can put it under x-axis, you can actually convert the properties by using the raw values. You can also replace it, and you're going to get a graph somewhat like this. So the graphs available over here is a line plot along with the scatter points. And in our script, which we have coded yesterday, I have also shown you that how you can manually create the graphs. Okay. So here we have checked the price, lot size, and all the graphs. Followed by, we have actually implemented the correlation analysis so as to identify what all features are influencing the price or the dependent variable, as well as finally we have plotted the graphs where we have displayed the lot size and the price. This was the scatter plot. Then we have drawn the line plot also. Okay. So similarly, the way you have executed this script, I'm again sharing the script with all of you, so that in case if anybody is watching this session for the first time, you can actually get started with us. So I'm just sharing that on YouTube again to all the participants. And I'm sharing it with the participants on our meeting also. So let's see. So under the chat, I'll just share the information. So if the faculty members also would like to test it along with me, you can test it. Okay, now here. So what you guys need to do, once you have reached to the script here, you can go to runtime and you can run all. Once you run all your cells over Jupyter Notebook will execute, and finally you will reach out to the output which we have achieved till yesterday. Okay. Now after this, what we can do on the same plot where you have actually plotted the sorted data with the line plot, over the same, you can actually plot the scatter also. So you can call plt.scatter, and within that plt.scatter, you can actually pass the values of sorted data of lot size as well as the data of the price. Okay. So once you run that, you will get the specific scatter points also at each and every location. Okay, so since the graph, and in case if you change the size of the graph so that it looks a little better, you can actually create plt.subplots, and using the subplots you can provide the access to the graph, so that once you plot the graph, you provide the access, it will eventually take that height and width, which we have already done when we have plotted the correlation analysis. So under the correlation analysis, using this statement, you can actually define the size of the graph, and you can provide the access value so that you can generate the graph of your own size. Okay. Now, so you can see that we can do both ways. We can actually work out on the data IKU, whatever we can do on data IKU with an easy drag and drop manner. We can do that with simple Python programming code also in order to perform analysis. Now, once we are done with that, now is the important part which we will be taking up, creation of the model. One thing which I would like to explain you before we start from here, let's start from right hand side. Okay, or I'll just say, what is your model, or create your first model actually means create your first mathematical equation. Mathematical equation. Okay, model is nothing but a mathematical equation. So if this is clear in your mind, then your life as a data scientist will be very easy. Okay, so there are various mathematical equations already available, and we can use those mathematical equations to identify whether our data fits or not. Okay, and what do we mean by fitting of the data? That I'm going to tell you. Now, before I proceed here, I would like to quickly share one information with all of you so that you will be able to understand what kind of algorithms we use with specific type of data sets when we create the models. Okay. So here, I want you all to refer the document which I have just shared, the Python machine learning document. And on this document, we have an article known as types of machine learning. Okay. So here is an article, types of machine learning, which I want you all to open. Now I would like to explain this article a little, and then we will proceed to implementation. So machine learning, overall machine learning, which actually helps you what will happen in future, is divided into three specific categories: the supervised learning, unsupervised learning category, and reinforcement learning category. These are the three different categories of machine learning. Now, when it comes to supervised learning, what do we have? In supervised learning, we have two types of equations. One equation is known as the regression equations. Another equations are known as classification equations. Okay. So what are these regression and classification algorithms? What are their mathematical equations? On what type of data it can fit? That I'm going to tell you. Similarly, so first I'll quickly explain right from the supervised learning part. So how do we identify when we have to implement supervised learning? So we actually implement supervised learning when the response variable is known. Okay. So when you know the response variable, then we actually implement supervised learning. And what do we mean by that? So we mean that the current data set which you are having, which is the house price data set, the response variable is price in that. And the values of the price is already known to us. Okay. So we have collected a survey, and the data collected from that survey has various variables, which includes information about bedrooms, bathrooms, lot size, and many more. Along with the response variable information is also available, which is the price. So in the cases when the response variable is known, we actually apply supervised learning. Okay. So we also call it as, generally the data is in structured format. Okay. So the data is in structured format. And what do we mean by a structured format? It could be a table representation of the data. Okay. It could be in CSV file. It could be in Excel file, etc. Okay. It could be the data in a database, kind of that. And this database is a SQL database. Let's say I'm going to type it, structured query language database. So if you have, okay, so if your response variable is known and the structure is in table format, CSV format, SQL database format, all these things falls under supervised learning. Okay. Now, we say the response variable is known, then the second question is the type of response variable. So response variable is of two types. Okay, it can be of two types. The first type is, I have already told you, it could be quantitative in nature. Okay, quantitative in nature, which means it's a quantity, a mathematical quantity. For example, the price. So price is a quantity. Suppose you have scored some marks in a test, it is a quantity. Similarly, let's say if you have purchased milk, so you have taken, let's say, 10 liters of milk, let's say, so that is also a quantity. So similarly, all these values which can be quantitative in nature are generally known as the quantitative response variable, and regression algorithms are applied on it. Okay, we apply regression algorithm on it. So regression algorithm works best when the response variable is of quantitative type in nature. Okay. And you should not get confused that after transformation, every value is going to be represented with a number. Okay. But number is just a representation. But the actual nature of the data or the response variable has to be focused. So in case if we have, let's say, a qualitative data, second type of data is qualitative in nature. Okay. And what do we mean by qualitative in nature? This is known as categorical data. Okay. So let's say if you have an example category data, let's say there is a field where we have to, let's say we have to predict employee attrition. Okay. So employee attrition is also a very common case in industry for data science. Now what generally happens with employee attrition is, suppose we have a data set where we have a number of information about an employee, like from how many years he has been working with the organization, what all certifications he has done, what is his experience with different technologies, what was his previous performance on different projects which were allotted, how many projects he is currently working on, what is the pay per hour which he is getting. All that information we can collect in a table format, let's say, and finally we can have a variable whether whether the employee is going to stay in the current company or he is going to leave that company. Because it might be possible that if a person is getting a good salary with less number of work, it could be possible he will continue with the organization because he's not under pressure. Otherwise, there could be a second case that there would be an employee who is working very hard and he is getting a very less amount, and he is getting a new offer where he can go to that other company and get more money for the same type of service which he is currently offering. So in that case, he may leave the current company. So employee attrition will be categorical in nature, where we have to predict where an employee will stay in a company or he will leave the company. So there will be two options in that response variable. It could be yes or no. And you can convert that yes or no into integers, let's say 1 and 0. Okay. So when your data is converted or transformed, it is also mathematical in nature, but it is not a quantity. It is still a category, because 0 defines no and 1 defines yes. So in that case, what we do, whenever we have qualitative data, we apply classification algorithms. Okay, we apply classification algos. So what all these algos are and which of these algos we apply, that I'm going to show you. So your life will become very easy, that you will be able to easily identify which equation works best with the data set which is available to you. So now if we quickly plot and if we see, if we are working towards a supervised machine learning, then we have quantitative data that works for regression equations, and qualitative data or categorical data, we apply classification algorithms on it. So this is what is supervised learning. And currently we have been working on the first part of machine learning. Okay, and but machine learning has a lot more to study. So this is the supervised learning part, and on hack with a one-to-one we have actually prepared three different course modules, and over these three different course modules under hack with a one-to-one, I'll tell you that once you are done with this session, because our current session will wind up on 15th, but it's not like that you are done with the complete machine learning part. You have to continue learning, and I'm just specifying certain courses which are available on one-to-one, that is free of cost. You can quickly log into your one-to-one account and get access to all these courses, and they are already available in your one-to-one account, so you can watch them. So first is data science and machine learning, which covers the supervised learning part, and some part of it for introductory purposes we have conducted in our this session also from 8 to 15, which we have conducted. Second part is machine learning unsupervised, where we have implemented agglomerative clustering using an accident data set. So we have been working on a project here, which is known as casualty severity prediction. We have another course known as unsupervised. Okay, so the project which we have done in this is causality severity prediction. So this is something related to accident data set, that in case if somebody gets an accident, depending on the environment outside, what is his probability of getting an accident, and what would be the impact of the accident which he may face depending on the lighting conditions and the weather conditions outside. Okay, so that is one project which you all can actually implement. Data science and machine learning, we have implemented the house price complete project, so you all can quickly observe that. Followed by the third part is reinforcement learning, deep learning, which we have been doing, where this course is known as AI and deep learning course. Okay, so that is also available, in which we have done various projects on neuroimaging. We will be taking up neuroimaging and handwriting. We have done on number classifications and etc. So it's a very nice course where we have done a lot of part on AI and deep learning, and the actual practical algorithms have been implemented right from perceptrons, sigmoid neurons, and everything is implemented here in AI and deep learning with restricted Boltzmann machines, and how you can use generative adversarial networks to create new images out of the data which you guys are normally seeing nowadays. So you would have seen on LinkedIn somehow that there is a person who is sitting on a camera, and on the other hand side there is a face of Albert Einstein, and here the person is trying to change his expression, and the photograph of Albert Einstein gets changed, and he is showing that expression. So how that generative experiences can be done, that all that part has been discussed in the AI and deep learning part, so you can actually cover that. Okay, but now I would like to quickly give you a quick comparison between all the three, and then we are going to implement it. So once you implement, you will not get confused that which algorithm to use depending on the data set which is available with you. Okay. So now, under the unsupervised learning, what we do when we implement unsupervised learning, the objective of implementation of unsupervised learning is in those cases where the response variable is unknown. Okay, response variable is unknown. So the data type, okay, the data type, it could be structured as well as unstructured. Generally, the data here is unstructured in nature. And what kind of data can be considered as unstructured data? I'll give you examples. So it could be text data, like let's say Twitter text. So the social posts which you guys do nowadays, like posting on Twitter, posting on Facebook, okay, etc. All this data is unstructured, as well as data in PDF, data in Word format, okay, images, etc. Videos. All these data fall under the unstructured part. So once you implement unstructured learning where the response variable is unknown, okay, we implement unsupervised learning. So unsupervised defines actually that the learning or training will be done without the influence of the response variable. That's why it is says unsupervised. There is no supervisor variable. There is no supervising response variable in that learning, and hence it was called as unsupervised learning. So there are certain algorithms for it. What are the algorithms? So algorithms generally which are available are clustering, which is generally used in order to perform identifying the patterns from the text. So you would have seen examples like sentiment analysis, and a lot of other examples are quite famous nowadays and which are actually used in the industry for various purposes. So sentiment analysis is an example of unsupervised learning over the text, and we have also made courses on that also, that is also available on one-to-one, which you can learn for all the different types of data types which is available. Now, apart from that, the next part is dimensionality reduction, which is actually to reduce the non-influencing parameters out. So this is an example of correlations actually. So under when the data is supervised, we actually calculate correlations, but when the data is unsupervised, we actually identify the similarity patterns, the similarity metrics, and generally we also perform principal component analysis here. Okay, I'll just type it here, principal component analysis. So that actually helps us identify the appropriate dimensions. Dimensions are nothing but the variables which is available in the data. So in machine learning, for the same entity, there are multiple keywords. Like for for the data which is available, you can call it as data set. You can call it as a data set with independent and the dependent variables. You can also call it as multiple dimensions of the data. Okay, so all these words represent the same thing, which is columns under the data. And as soon as you proceed to reinforcement learning, this is something where you would have seen the examples of learning from the environment. So self-driving cars and all that stuff which is latest coming, like your drones. Okay, I'll just type it here. So under the reinforcement learning, we have self-driving cars, etc. Okay, we have drones which can. Here, what generally is done, learning is done in an environment, in an environment where the objective is to maximize the credit. Okay, so for every action which is performed in an environment, there is going to be a positive credit and a negative credit. So the objective is to maximize the credit by performing the actions. So this is something like learning from the environment itself. So self-driving cars, what they do, they quickly process the images of the certain area, and they identify whether if they are moving on the track. And just to identify the perfect track, what they do is they learn from the environment by going into various paths, and then it identifies which one would be the best path where the credit score will be maximum. So it actually adds to that path in the main execution process, and then it continues. So that is the part of reinforcement learning, which is generally helpful. Okay, so all these things, these are the three specific categories of machine learning. And now what we will be doing today, we will be implementing with the regression part, the first part, so that you guys will get a clear idea that how we will be processing. And why I am taking regression, because I'm taking regression because the data set which I have taken is having the response variable as price, and price is quantitative in nature. So when the data is quantitative in nature, regression algorithms will work best on it. If I apply reinforcement learning on it, it might be possible that it won't be able to predict it in the appropriate way. Okay. Now, so let's continue from here, what and how you are going to implement that. So let's just quickly go to the analyzing house data set and creating the first model. So the first model which will be created will be the regression model. Okay. And why we will be creating the regression model? So we will not create the regression model, but since the data type is quantitative in nature, the response variable is quantitative in nature, we will be applying multiple algorithms on it. We will be applying the algorithms of classification, and we'll be applying the algorithms of multiple types of regressions, and we will check which algorithm works best. And eventually you will get to see that since the response variable is quantitative in nature, finally the regression model or algorithm will be working. So just to give you a quick look of what is a linear algorithm. Okay, what is a regression model? Okay, so this is the general linear regression equation. Okay, y is equal to m into x plus c, where y is the dependent variable. Okay, which is price in our case. Second, we have m. M is generally known as coefficient of determination. Coefficient of determination. Okay, so this is the important factor, and generally we also call it as slope. So why we call it as coefficient of determination? Because the values of x will be same, but with the coefficient of determination we will be able to actually calculate the coefficient in such a way that when we multiply that with the original value of x, we will be able to get the accurate value of y. Okay, so that's why we call it as coefficient of determination. Followed by you have x, which is the independent variables. Okay, and we have approximately 11 variables are there. For example, like bedrooms, bathrooms, etc. They will be your independent variables. Okay, etc. So we will be using these as your independent variables. And finally you have c, which is known as residue, and this is value of y when x is equal to 0. Okay, so this means these are the hidden factors. We also call it as the hidden factors in the data. Okay, so hidden factors in the data, which means that it might be possible that the data set which you have does not have uh, some factors which may actually be influencing the price. And it says, in fact, if the independent variables are all 0, okay, and still if you get a price, let's say 4,000 or 5,000 rupees of a house, so that means there will be some hidden factors also which were actually responsible for the price. So for them, we actually call them as residue. So these are some of the important things. So initially, what generally we do? So there are two steps which we actually perform. The first step in the analysis, sorry, I'll just type it here, machine learning steps. So there are two steps. One is training the model, and second is prediction using the model. Okay, training the model and prediction using the model. So what do we mean by training the model, and what do we mean by prediction using the model? That's what I'm going to tell you initially. Okay, so let us just quickly understand about what do we mean by training the model. So suppose how the process will start. Suppose we have the data set available. Okay, we have the house price data set. House price data set is available to us. That is the prepared data set, and we have identified that price is going to be the response variable for us. Okay, then after the price, we have actually identified the price is quantity. Okay, so since the price is quantity, as a data scientist, what I will do, I will quickly search for regression equations. So due to quantity, what I'll do, my second step would be select a regression equation. I'm going to select a regression equation. So suppose, what is the regression equation? My regression equation is y is equal to m into x plus c. This is going to be the first equation which I'm going to test with my data. And in case if this equation is good enough to predict or calculate the predictions of the price, then what I can do, I can continue with this equation and I can integrate this equation with my website or with the mobile application so that users can use this. But in case, let's say this equation does not work and it gives me a prediction or the accuracy less than 80%, then I'm going to ignore this equation and I will go for other equations which can be applied on my current data in order to calculate the best outcomes. Okay, so I'll show you how the training process will be done. So when we start the training process, we have selected the data. Now we start training the model. Okay, what do we mean by start training the model? So given the value of x and y, given the value of x and y, we have to calculate values of m and c using using the using the identification equations of coefficient of determination. Okay, and I'll show you how and what that equation looks like. Okay, so what generally we have to do, given the value of x and y, we have to calculate the values of m and c. M is generally known as coefficient of determination, and c is generally known as the intercept. Okay, so this is the intercept, and also it is known as residue. Okay, and coefficient of determination is also known as slope of the line. Generally, y is equal to mx plus c is also known as a straight line equation. We also call it as a straight line equation. Okay, so we apply this straight line equation when we see that the independent variables are linearly associated or influencing the outcome. Okay, so in that case, it actually creates a straight line, and we apply straight line equation in order to identify the coefficient of determination and slope. And how that works, first I'm giving you a quick simulation about how things happens behind the scene, and then we are going to test that with Python programming as well as with Dataiku. So अब आप लोगों को समझना है that given the values of x and y, so x and y की values given कहाँ हैं? x आपके independent variables हैं, जैसे कि bedrooms, bathrooms, lot size, gas hot water, preferred area, garage places, and y is your price. So price of 45,000, 80,000, 20,000 US dollar, whatever it is, both the values are given to you in the data set. Now, once you put both of these values, let's say on y, and once you put the values of, let's say, y here, okay, and once you put the values of x, I just use this one. Okay, so I'm going to push in the values of y here, I'm going to push in the values of x here, and using the values of y and x, we have to calculate m and c. Okay, so how can we calculate m and c? To calculate m and c, we do have a slope equation, and I'm going to refer you that. So to calculate m and c, we have slope equation. Okay, so how we will be using the slope equation? Generally, behind the scene, when we actually call fit on using a linear equation or any of the algorithm, generally this calculation is done behind the scenes. Okay, but first I would like to show you how it actually works. So over a website, you can actually open google.com. Over google.com, under the search, you guys can quickly search slope equation. Okay, you can actually search for slope equation, and here you can see here is the slope equation, y2 minus y1 upon x2 minus x1. This is the slope equation, and we will be referring to this slope equation from the statistics slope equation linear regression. Okay, that's what we need to actually check. So on the website linear regression statistics howto.com, which I have already recommended you in the previous sessions, is one of the nicest blog where you will get the complete information about this. Okay, so whatever I'm explaining is also available over here. You all can quickly refer to it, and I'm just posting the information on the Trello card also. So I'll just write it here. A slope equation for linear regression. Okay, so here this will be the equation. I've saved it on the Trello card. You all can quickly observe it, as well as I'm sharing that. Okay. So here you can actually push your, here you can see your, the information which I have shared here. Okay, now let's see. So now what next you can do, you can actually see the slope equation here on this article. So I'll just show you what is the simple linear regression. Every information is defined over here. And here you will actually see the linear regression equation, that how y is equal to mx plus c is actually calculated. So on the top right corner, if you all can observe, this will be your equation. Okay, let's see, I'll just keep it here. On this side, I will quickly set this up. So now what you can see is, let's do one thing. Okay, just give me a moment. I'm just quickly selecting that for your reference. So this is the equation. Okay, to calculate A and B generally. Okay, so I'll just quickly show you the reference. So generally what happens is, here the definition says linear regression is a way to model the relationship. Let me just clean it, I guess that will be better. Okay, here. So guys, you can see the linear regression equation is defined over here. It says linear regression is a way to model the relationship between two variables. You might recognize this equation as a slope formula. So this equation which you are actually observing is a slope formula. So the equation is of the form y is equal to a plus bx. Here a value is actually the residue which I am talking about, which I have represented with c, and b is the coefficient of determination. X is your independent variables and y is your dependent variable. Okay. Now, when you will put the value of summation of y, summation of x square minus summation of x into product with summation of xy divided by number of elements with the x square minus number of summation of the elements of this, n would be the number of observations. Okay, number of observations with a product with x square minus summation of x whole square. So this information is going to give you the information of residue, or else you can also call it as the intercept. And the second equation, number of observations, summation of xy minus summation of x into summation of y with divided by number of observations with a product of summation of x square minus summation of x whole square. This is going to give you the value of slope, which means m, which we are referring in our equation y is equal to mx plus c. Okay, so this equation is known as the intercept, identification of the intercept. Okay, and the second one is the slope, which is also known as coefficient of determination. So you can see that given the values of x and y, what you can do, you can actually calculate the variables of slope and the intercept. We also call it as residue. Okay, I hope this is clear to everyone. Now, once you are done with calculation of intercept and slope, what can be done? So now you can modify the process in such a way that you can actually calculate the predicted value of y. And how you can predict the value of y? You can use m into x plus c. And from where you are going to get this m and c? You are going to get this m actually will be your coefficient of determination. C is going to be your residue, okay, and X is your independent variables which are already available, and this could be the independent variables in the testing data set. Okay, independent variables. I will type it as independent variables in test data set. Okay. So using that, what we can do, we can actually able to calculate the predicted values of y. Okay. So y predicted will be calculated. Then what we have to do in the next step, we actually compare the values of actual x, actual y, and predicted y. Okay. So what we are going to do, we generally calculate the loss using actual y. Let's say, let's call this predicted y, or I'll type it something like this: y predicted minus actual values of y. Okay. So using this, we are going to get the loss, and if loss is very small, okay, that means the model will be high accurate. Okay, the accuracy will be high of the model. Okay, I hope you understand this. So what we are going to do, we generally calculate the loss using the values of y predicted and y, and it gives us the loss. So if the loss is very minimum, that means linear regression equation is good in order to calculate or predict the value of y. So if the value of y predicted and y is actually close with respect to the same data set which is available, then we can use this equation for integration with the web application and the mobile application. And this signifies that the equation will fit the data set. Okay, will fit the data set in a good way. So this is what machine learning is all about. You will be given a data set. Depending on the data set, you're going to select an algorithm. You're going to put the values of x and y on it, and you will be calculating other variables which are available in that mathematical equation. How will you be calculating those variables? By individual formulas available for calculation. So similarly for the linear regression, as we have the slope formula available, we actually calculate the slope and the intercept. Once we are done with that calculations, then we can actually put the actual values of x again, multiply them with m and c, and once we get that, we actually calculate the predicted value of y. And if the y predicted and y actual is very close to each other, that means the model is good. If the y predicted and y is far from each other, that means the model is not good, and we can search for other mathematical algorithms or the models which can actually close this relationship of predicted and actual values. Okay, so this is something which we generally do in machine learning. So now how that is going to be implemented. So as I have already told you, this is how we will be doing it. And let me just quickly show you the previous image which I have opened. So I'm going to refer that again, and I'll just quickly show you here. So this was the image which I was talking about. Let's say, okay. Now, okay, now let's see. So we have implemented this, that you are going to start the training given the values of x and y. We have to calculate the values of m, that is slope of coefficient of determination, and c, that is the intercept and residue. And to calculate the m and c, we have the slope formula or the slope equation. Now in the third step, what we will do, in the third step, once the values of m and c are identified, we calculate values of y again and compare. Okay, we calculate the values of y again as y predicted. Okay, let's call this y predicted. Finally, and in the fourth step, we compare values of actual y and predicted y. If the loss is very small, let's say above 80% accuracy, then we can say that the model is good. Okay. then you can actually say that the model is good. In case okay, so if you have if the loss is very small and the accuracy of your equation is above 80%, then you can say the model is a good fit. Okay, I hope this is clear. So in Python programming, you will be doing all these steps, which means you will be actually working on training the model and prediction using the model. So generally there will be 4 commands which we generally use. First, we initialize the equation. So let's say I'm going to initialize a regression equation somewhat like this. Let's say linear regression. Okay, and I'm going to save that into something like LR, let's say. That is going to be my linear regression model. Then using this linear regression, I'm going to fit the equation and I'm going to pass the values of independent variable and the dependent variable. And once I have done the fit, okay, I'm going to save it as a model. Okay, once I fit, I get the model. Okay, so LR actually itself is the model itself. It is the linear regression equation. So what you can do is you can actually fit it directly. You don't need to save it anywhere. You can directly call it as fit. And once you are done with the fit, after this stage, you will actually get the values of, this will actually calculate MNC. This will return you the values of MNC. Once you have the values of MNC, you can actually predict by giving the values of X, and you are going to get Y predicted. Okay, and then you are going to calculate the loss or the accuracy by Y predicted minus Y accurate, or Y minus Y predicted. Both ways you can do. Okay, so this is how, these are the 4 steps which we generally do. So the on the left hand side, I have explained each and everything. So let's say if you're going to select the linear regression equation, you're going to define it like this. Let's say given the values of X and Y, you will train the model using LR.fit. Then once the MNC is identified, you are going to actually calculate the predictions. So the equation will be somewhat like this, LR.predict, and you're going to get the predicted value. Finally, you're going to compare the model, okay, using the accuracy and everything, as well as by plotting the graphs. Okay, so 5th step actually is plot the graphs. Plot the graphs between actual and predicted, for better visualization, for better visual understanding. Okay, and this information actually can be shared with the stakeholders or else with the consumers, that this is what is happening and this is the critical insight which has been identified from the data. Okay, I believe this is very clear to all the participants, that you have the house price data set. It is going to return you, you have selected the price as the response variable. It is quantitative in nature, hence I selected regression equation. I have applied values of independent variables and the dependent variables in that equation, and I have used slope equation to calculate MNC. Once MNC has been calculated, we have actually predicted the values of Y, and after the value predictions, if the loss is less and the accuracy is more, then we can use that equation for production purposes. We can also plot the graphs for actual and predicted values between actual and predicted. In the similar way, we have yesterday plotted for lot size and the price and so on. So that we can do, and with the visual understanding, if we have got a good equation, if we have identified that this equation actually fits the data best, then we can use it for machine learning. Okay, so this is something which could be considered as your complete implementation of machine learning. Okay, so which includes 4 steps: initialization of the equation, training the data, prediction using the data, and finally calculating, interpretation and evaluation. Okay, so what I'll do is, again, I'll just quickly specify. This is you have 4 steps which you will be doing just now. So first, you will be initialize the equation, initialize the model, or whatever the equation it is, training the data, training using data, training model using data. Okay, third, prediction using test data, and fourth is evaluation and interpretation, evaluation and interpretation using accuracy and graph. Okay, so this is what these will be the 4 steps which you will be actually implementing in machine learning: linear regression, training the model, prediction using the data, and finally interpretation and evaluations and plotting the graph. So please confirm me if you all are clear with the concept of what exactly, how the data science will be implemented. Now let's go and just run it. Okay. So what we'll do, let's quickly go back to the code now and we will start implementing it. I'll close it. I'll just clean my screen so as to quickly take you back to the creation of the model here. Okay. So before we go for creation of the model, let's just quickly implement that practically in Python, how that will be done, the 4 equations which I have actually shown you. And then I'll show you how using Dataiku, you can compare a number of algorithms in order to gain the appropriate insight. So now what we have to do, we have to perform the 4 steps. So let's say this is the machine learning part which we will be implementing. Get started with machine learning. So step one will be, you will have selection of independent and dependent variables. Independent and dependent variables. Okay. So if I show you the column names inside the data variable, okay, so the data, I'll just quickly check what variable we have been using. We have been using data.correlation. Let us just run all. Just the script which I have shared with all of you, you all can quickly run it all. And once you all have done run it all, then we are going to print the columns values. Okay, here. So if you can see, if you print the columns, you have the price. This is going to be our dependent variable. And then we will be having the preferred area. No, sorry, then we will be having the independent variables. So let's just quickly take it. So what am I going to do? I'm going to call data.price and I'm going to save it into y. Let's call it as, this is going to be my dependent variable. Okay. Then what am I going to do? I'll take other variables as the independent variables, which we have already taken yesterday as well. But one more thing we can do, let's just call it as independent. Let's create a variable independent and let's store all the columns values in it. Okay. And from this independent variable, I'm going to delete the price, which is at first index. And after deleting it, I'm going to save it again into independent. And once I've got the independent within X, I'm going to store data of independent variables. Okay. So let's run this cell. So we have got the values of X and we have got the values of Y. This is going to be the independent variables. And before we run further, if you want to see the values of how the Y looks like, so Y will be having the price information. Okay. And X will be having all the other variables like lot size, bedrooms, bathrooms, stories, up to preferred area, and everything is in number format. Okay. So we have the values of independent as well as the dependent variables available. Now what next we are going to do? We are actually, since the type of the data.price is quantitative in nature, you already know about it. So we are going to make use of regression equation. Okay. So since the price is quantitative in nature, use regression equation. Okay. And regression equation is equal to y is equal to mx plus c. But here in Python, you can quickly import it using sklearn. There is a library sklearn dot models dot linear model. Okay, you can import sklearn dot linear model as lm, Okay. So within this linear model, if you run it once, if you call lm and dot is the scope resolution. So you can see that it has multiple linear models are available like ARD regression, Bayesian ridge, elastic net CV, hinge. These are all the algorithms which are appearing in red color. Lasso regressions, lasso lats regression, lasso lats CV. So I'm going to show you that these are the different algorithms with linear models like logistic regression, modified Hopper. You can apply all these algorithms, okay? And whichever algorithm gives you the best accuracy, that is your algorithm which you can use for production purpose. So it may be difficult to do it programmatically and compare all these algorithms, okay? So what you can do is you can make use of Dataiku where existing algorithms are available, or else there is another way where we can deploy multiple algorithms in one single code. So that also I'll tell you, or else you can watch our videos on Hack with a one-to-one where multiple algorithms, how they are used. We have implemented a project with breast cancer prediction. So there we have compared multiple algorithms. So you can have a look on one-to-one platform. So for now, we will be using, let's say, linear regression to make you understand how that works. So we have saved that linear regression into LR object. So LR becomes, okay, and just if you don't want to get confused, let's call this variable as model, okay. So what is a model here? Model is an equation, and currently in our case, the model is a linear regression equation. Now what we can do, once we are done, we can train the model, okay. For training the model, what generally means by training the model? So training the model, what it will do, you are going to use ordinary least square linear regression. Let's say linear regression fits a linear model with coefficients to minimize the residual sum of squares between the observed targets in the data set and the targets predicted by the linear approximation. So there will be certain values which you are going to provide. You're going to provide certain parameters, and depending on that parameters, you're going to get three attributes. First attributes which you are going to get in return will be coefficient attribute. Okay, this coefficient attribute is actually the coefficient of determination, which we actually call it as slope, the values of m. And similarly, there is another attribute known as intercept, which will be returned once you train the model. So this intercept is actually the value of residue, the value of y when x is equal to 0. Okay. So now what we are going to do, we are going to train the model. So to train the model, what we generally do, we use model.fit. Okay, fit uh, is the function you can call model.fit. And what generally happens in model.fit, model.fit will have your model.fit will have your independent variables x, the dependent variable y. Okay, both of these information will be available. And what it does, x is going to be the training data, the data of lot size, bedrooms, bathrooms, and so on. And y is going to be the target values, the response variable, which will be the price. So we are going to put both of these values, and once we execute that, it is going to return an instance of linear regression model. And within that model, we will be able to identify the values of coefficient as well as the intercept. Okay, and that coefficient and intercept in the background will actually be calculated using the slope equation, which I have already showed you on the statistics how to website. Okay, so as you all can see, first we have to provide the values of independent variables and followed by the dependent variables y. Okay, so we have provided the values of x and y, and this step is known as fitting the model. So once you fit the model, you can actually save that again into the model, and let's run it. So once we have done this fit, now the training has been done. See how quick the training can be done. Now after the training, what will be done? Objective of training, objective of training the model with input data set of dependent and independent variables is to calculate the attributes. Okay, is to calculate the attributes. For example, the attributes like slope and intercept. Okay, which can help in prediction, of response variable. Okay, so this is something which you guys have to implement. So you have imported the linear regression, you have fit the regression equation. So what am I going to do now here? I'm going to show you print the slope and intercept. Okay, so what am I going to do? I'm going to write a print statement, and I'll say the slope of equation is, let's say, the slope which is m as per the linear regression equation m, okay, is, and it's going to be model dot, there will be the attribute value coefficient. Okay, coef, this is going to be the coefficient value which will be calculated using the slope equation in the background, and the intercept, or else you can call it as residue, which is c in the linear regression equation, is, and this is going to be a model dot intercept. This will be the second value which you are going to get after the training has been completed. So what training gives you? Training gives you these parameters. It is going to give you the value of slope and the intercept. Okay, so we have got the values of slope and intercept, which means we have got the slope for every individual attribute, and we have seen that in case if no attribute is provided, there won't be any money. So there is a sample error, like the price, if we do not provide any information like bedroom, bathrooms, or anything like that, the price will be minus 2981, something like that. So that is due to maybe something. Okay, so you have the model and you have the intercept now. And using this model and intercept, what next you can do? Now your model is ready. You can predict using the model. Predict using the model. Okay. So how we can do? We can actually calculate the value of y predicted using model dot predict. Okay. And now we can give the, let's say in this case, generally we give the testing set. We do not give the data of the actual, the data which we have used for training the model. Generally we keep a separate testing data set, and we provide the values of testing data set so as to check whether the predicted values are good enough or not. But in our case, let us just test it with the original values of x only, so that you guys will get a quick comparison, that once we have actually performed the prediction will be different from the actual values. Okay, because here the machine is trying to predict on the basis of the observations. So we will see what will be the prediction values. So let's just run it. You're going to get the value of y prediction. So we have done the values of y prediction. The prediction has been done. And now we are going to show, perform interpretation and evaluation. So how we can actually do interpretation and evaluation? Let us just quickly see. We can actually see the accuracy of the model. Okay. So in order to calculate the accuracy of the model, there are various ways which we can use from sklearn.metrics, as well as, before I show you the metrics, okay, or else what I'll do is, let's just import sklearn.metrics. Okay, or else what you can do is, you can from sklearn.metrics, okay, you can import the values of R2 score. Okay, what is R2 score? That I'm going to tell you. Then we have mean absolute error. Okay, you can have mean absolute error. This is also we can check. And root, you have mean squared error as well. Mean squared error. These are some of the metrics which we generally use for calculation of whether the regression equation is correct or not. And how do we get to know about it? So let's say in case if I quickly search on Google about linear regression, so I'll get to know that linear regression can actually be evaluated using the mean absolute error, and something like that. Okay, so let's say, so quality of the linear regression equation can be actually checked with your information like mean absolute error and the R2 score. Okay, so generally if I quickly show you what is R2 score here, you will quickly get that information, R2 score. So here, what is R squared? R2 score actually generally means for R square, and that is known as the coefficient of determination. So in statistics, the coefficient of determination, or else the value of R square, or generally pronounced as R squared, is the proportion of the variance in the dependent variable that is predictable from the independent variable. So the proportion of the variance means you have the actual values of y, you have the predicted values of y, and the variance between actual and predicted values of y can actually be calculated with your what we call the R squared matrix. Okay, so if the value of R squared matrix is less than and close to 0, that means the accuracy is not good. If it is close to 1, that means the accuracy is good. So here it says how you can actually identify it. So in both the cases, the coefficient of determination normally ranges from 0 to 1. So this is like percentage it calculates. So if you have got a value 0, that means the model is very bad and it will not be able to predict the values of price accordingly if the value is close to 0. But if the value of R square is above zero point 0.8 or so that means it is above 80% accuracy. So if the accuracy is above 80%, then we say the model is a good model and we can use that model for prediction of further values or further variables. So this is what we generally do. So now how you are going to quickly calculate the R square value, that I'm going to tell you. And similarly, like R squared, there are other error calculations also, which is mean squared errors and mean absolute errors, which you can actually check back. So let us just come back here. From sklearn.metrics, we have imported R2 score, mean absolute error, and mean squared error. So what we can do is we can actually call this function R2 score, and let's just quickly first run it. We have got a information. Call R2 underscore score. What R2 score will give you? R2 score is the coefficient of determination, which is the regression score function. And regression score function will actually let you know whether the regression equation which you have with the current data set is effective or not. So how will we be able to check the effectiveness? We have to actually achieve the best possible score, which is nearest to 1.0. It can be negative because the model can be arbitrarily worse. A constant model that always predicts the expected value of y disregarding the input features would get an R2 score of 0. That means the model is a bad model. So we will be testing the R2 score and we will see what will be the value which we will be identifying. But we actually need that the value should be near to 1. So however, if it is close to 1, that means the model is going to be a good model. So how we actually check the accuracy? So we check the accuracy by providing the actual values of dependent variable followed by the predicted values of dependent variable which we have calculated. Okay. So the actual values are y, which we have already calculated. The predicted values is y predicted. And we are going to get the value of R2 score. So let's save it into R2. Okay, I've got some annotations here. Is there anything which anybody wants to say? Okay, so here we have R2 score, which you have calculated here. Let's just print the R2 score. So we can say the R squared value is, okay, and we can actually print R2 here. So once we print the model value of R2, so you can see that we have got a value of 0.064. So that actually means the accuracy is 64% of the model at the moment. Okay, so that means there could be some problem within the data. So the data which is available actually suffers with variance inflation factor, and once we remove the variance inflation factor, we will be actually able to achieve the accuracy of approximately 97%. Okay, and that we have already discussed on our course, that is one-to-one, over the one-to-one. When we have developed the house price project, we have actually created that appropriate variance inflation factor. So variance inflation factor is also a very nice concept which you all have to actually explore. I'll just give you a quick insight about it. So what variance inflation factor is, sometimes what happens is there are certain independent variables which are highly influencing to each other in the data set. Okay, so in case if we identify any such factors where the variance inflation factor value between two independent variables is more than 10 or more than 5, then we have to actually account the contribution of only one variable. Okay, so that means, let's say if there are two variables like stories and bedrooms, and they are highly influencing to each other, and the variance inflation factor value of both of them is above 10, so we are going to count only one. We will delete one value, one column from our data set, and once we remove the values of variance inflation factor based columns out of the data becomes more analysis friendly. Okay, and you will be able to achieve high R2 score. So over the one-to-one, we have discussed how to calculate variance inflation factor, and I'll quickly show you here. You can go to hackweather.in/one-to-one, and once you log into your account, you're going to get a dashboard. Over the dashboard, you will actually get this program on data science and machine learning. Under this data science and machine learning, there is a complete lesson which we have discussed on variance inflation factor. So this is the session, model performance tuning by multicollinearity removal using variance inflation factor. So once you have actually got the model, and if you sometimes find that the accuracy is less, and if you have to performance tune the model so as to improve the accuracy of the model, then we check with other options, and for regression it is multicollinearity issues, so we remove the multicollinearity by using variance inflation factor. So you can follow this session and you will be able to understand completely about how variance inflation factors can be removed. But for now, let's say you have got a model, and the minimum accuracy of the model should be at least 80%. Only then it will be good to use with a web application or the mobile applications, as well as it is much better if it is above 95 or 96%, then it is like too good. Then you can actually use it. Okay. Now let's see. So we have got, I have already told you that you can actually import the equation, you can train the model, you can predict using the model, you can check the interpretations and evaluations. Now we are going to perform the interpretations and evaluations using the graphical model. So as I have already told you that you can actually make a plot out of it. So what we are going to do, let's say in the data, I'm going to add a column, let's say predicted price. Okay. I'm going to add a new column, predicted price, and I'm going to save the values of YPRED in it. Okay. So once I have saved it, now in the next line of code, what am I going to do? I'm going to actually show you three columns. Okay. The price column from the data, and let's say we will be comparing it with lot size. Okay. Since there are many more factors, but we will be just comparing it with the lot size, that for a specific lot size, what is the price of a house and what is the predicted price of the house. Okay. So that's what we are going to compare. So let's say we are going to use data of price, lot size, and predicted price, and I'm going to show you. Okay, just a minute. During handling, another exception occurred. Price key error. Okay. Predicted price. I have already added predicted underscore price here. Okay. Let me just quickly check. Data, yeah, I've got predicted price. Okay, what I'll do is I'll just pass it like this. So you have to, it's a multi-dimensional data. So you need to, for the index, you need to use square brackets here. Double square brackets is required. So use price and followed by, let's take a lot size. Okay. And after the lot size, we are going to actually get the values of predicted price. Okay. So similarly, you can identify the values of any specific columns out of your data. So now, as you can see, once I have got the predicted price, you can see there are certain variables where, let's say, the price, actual price was $42,000, lot size was 5850, but the machine is predicting that the price should be around 60,664. So here there is a huge difference between the price. Okay. But somehow, as soon as you go down and as soon as you progress further within this data set, you will actually observe sometimes the observations are very close. Let's say the actual price is 60,500 USD and the predicted price is 62,380. So this is in fact close to each other. Okay. Similarly, here you can see it is 49,500 and it says that the price should be approximately 46,290. So depending on the equations and whatever factors have been identified, the predicted price data has been calculated by the algorithm. The problem here, the difference here is actually because we have only got the model of 64% accuracy at the moment. But once you remove the variance inflation factor, you will actually get 97% or very high accuracy, which you can use for prediction. Okay. So this is how we can quickly compare that what is the actual price and what is the predicted price which we have used, which we have calculated using linear regression. So this is just with one equation. You can try with another equations, like you can try with another logistic regression equations. Logistic is generally used for category, but another equations like ordinary least square regressions, and there are other regression algorithms also available which you can test and you can see which one performs best and which can give you better accuracy. Okay. So once you have got the perfect equation which can give you the highest accuracy, you can use that equation to be used with your web application. Now we will be working towards the final step, and the final step would be in order to just plot the graph. Okay. So what we will do, interpretation and evaluation using graphs. Okay. So once you have got this, now what we are going to do, we are going to use PLT. We are going to use the scatter plot. Okay. So we are going to plot the x-axis. Let's say the x-axis is going to be the lot size. Then we are going to get the y-axis. The y-axis is going to be the actual price. Okay. And let's say we are going to have the color. So we are going to have the color property. Let's say the color property for the actual values will be, let's say, green. Okay. So once you plot it, let's say you're going to get a plot somewhat like this. Let's just quickly label it plt.scatter and let's just get the predicted price also. Okay. So we are going to get the lot size will be on the x-axis, and on the y-axis we will have the predicted price also. Okay. Let's do one thing. Let's just calculate price here on the x-axis, predicted price also on the x-axis, predicted underscore price also on the x-axis, and on the y-axis we will be having the lot size. Okay, lot size, because for the same lot size we will be comparing, and the different values of price will be displayed to you. And let's say this time the color is going to be red. For that, we are going to make some labels. Let's say we are going to have an X label, which will actually define price in USD. We are going to have a Y label. Let's say we are going to call it as lot size in square meters. Okay. And we are going to have the title, plt.title. Let's say we are going to call it as machine learning with actual versus predicted. Okay, actual versus predicted. You're going to get a graph somewhat like this. So now you can see that for the specific lot size, you can see that the values of red color are the predicted prices and the value of green color is the actual prices with respect to the lot size. So now we can grab the conclusions here that generally the data for the popular type of variables which generally fall in this range, we can actually calculate those values appropriately, okay, for this particular range. So we got this conclusion that if we actually compare the information for this range, the data we might get the close results. But if the price is extremely high, then the model is unable to predict it. Okay, the model is actually able to predict the prices up to this area, square yard. Above that, it generally fails. Okay, so this is how something which we got to know from the inside, that the price in USD is represented on the x-axis, lot size in square meters is represented on the y-axis, and depending on that, we have actually checked the difference between the actual data and the predicted model. So now the objective of the data scientist is to add in more features in order to increase the accuracy, or else check if there is any problem in the data set. So he should clean that data in order to achieve more accuracy. There are certain parameter tuning techniques also available with different algorithms so as to improve the accuracy. So that you will be learning as soon as you will be progressing with the data science technology, you will be learning all that stuff. Okay. Now, so once we have got this, let us just see the difference, the actual difference between both of them. So what am I going to do? I'm also going to draw a line plot with the sorted values of price in US dollars. Okay. So let us just compare the actual model, actual versus predicted model. Okay. Now we are going to have a quick comparison about how the prediction is going to happen. So let's say I'm going to have a plot this time. On x-axis, I will be having the sorted values of the data, and out of the data, I will be having the price, followed by, let's say, sorted values of price. And secondly, we will be having the second values will be data of, let's say, lot size. Okay, and we are going to get the line color as, let's see, green. Okay, we're going to have a green line. Let's just plot it. Let's see if it shows you the appropriate information. Color is not here. Automatically, the plot is going to take that, or else you can use the C map, color map, in order to specify the line segment. Okay, must use keyword argument for key function. Okay, I think I got one. I've closed that here. This was the second one. Then we have the data of the lot size. Okay, what it says, must use keyword argument for the key function, plt.plot. I just quickly check back. So here, let's just quickly check back the plot. So plot actually says we can pass the values of plot y versus x as lines in the markers. So we are going to give the values of x, we are going to give the value of y, that is going to be the lot size value. So we can use plot x and y directly. Okay, so let's just go for it. Plot of data of price first, followed by the data of lot size. Okay, we got this. Let me just quickly draw it first. So we got a matplot somewhat like this. We have already plotted that once. Let's just use sorted here. Okay. So once we have sorted the data, we have got the actual price sorted in this manner. Okay. Let's say one line has been selected. Second, what we are going to do, let's make another plot. This will be for the data of the predicted price. Okay. And let's say we are going to have the another one will be for, again, I've got into this. Okay. Let's say we'll be having data of the lot size. So this is the second plot, which we will be having the line plot within that. So you can see that orange color actually shows you the the model, and the blue line actually shows you the price of the actual prices. So now you can see that since the model is 64% accurate, so it actually follows the way this actually the data actually represents. So model is somewhat 64% accurate to calculate the prices. Where the values are low, it is able to calculate that. Where the values are high, it is able to calculate that. But somehow there are certain cases, like this case you can see. The model is unable to calculate this price. It is unable to calculate these prices. It is unable to calculate the price of houses with very high lot size. So due to this, it is not 100% accurate. Okay. So this could be due to some other factors which may be available in the data set. Like there are two factors. Stories generally influence the price of the house. So once any factor which is positively or negatively highly influencing the another independent variable in the data set, we are going to remove it, and then we can actually get more accuracy, and then you can plot in order to ensure that you will be actually able to predict the price closely. Now what will happen? So if you have got a model like this, then what we can do is we can actually make an application where we can feed in the values of house and everything like that. What is the, how many bedrooms you have, how many bathrooms you have, and finally it can actually calculate and predict the price for you. Okay. So let's just go for the final step, that how we can do it. So this time, in this, using this model, we are going to make an application, make a simple application app, which can predict price, using the model. Okay. So now this time you don't need to perform any if else statement. You have got a model, and using that model you can predict the price for any new data coming into the system which is not available in your specific data set. Okay. So what we are going to do, let us just quickly make a simple app here. So this is going to be a command line app which we are going to test. So let's say we are going to say, let's say we are going to create a user data. It's going to be an empty dictionary, and using this user data, this is going to be the custom user input which we will specify about bedrooms, bathrooms, and so on, and we will be predicting the price. Okay. So what we are going to do, let's say, so for variables in independent variables. So as you can see, now what is actually required for each independent variable, you have to specify the information like how many bedrooms you want to have, how many bathrooms you want to have in a house, do you want a garage place in your house, do you want gas, hot water in your house. All these questions will be asked, and depending on the user input, the approximate price of the house can be told to him. Okay. So how that can be done, let's have a look. So we are going to have an input for each and every feature. We are going to call it as enter. Let's say we are going to add the name of the variable here. Okay. So it will ask generally enter bedrooms, bathrooms, lot size, whatever variables are available in the independent features. We are going to get that, and it is going to return you a string value, which we are going to save it in the under the temporary value. And under the temporary value, using this user data dictionary, we are going to actually add a key known as variable, and for that key we will be storing that temporary values. So now this is a simple data structure in which automatically all the variables will be asked. We are going to input the values of bedrooms, bathrooms, lot size. All that information will be stored into a user data dictionary, and then using this user data dictionary, we are going to create a data frame. Okay. So how you can do it, you can actually import pandas here. Actually pandas has already been imported because we have read the CSV file. So you can actually create a random data frame which is known as pd.dataframe. Data frame is nothing but a two-dimensional, size mutable, potentially heterogeneous tabular data, which I have already told you all that how we can represent the tabular information in the in Python, or else using pandas you can show the complete table, 2D data, and you can process it. So the data, we have to provide the first value, which is the data value, and within this we are going to provide the user data which we have generated. The second is the index. How many rows would you be having? So we will be adding it to index number 0. That means we will be only having one row in that user data frame. Then you have to provide the information of the columns. Okay, so columns will be your independent variables. Okay, so we are going to get a data frame and let's call it as input. Okay, this is going to be the user input. Oh, okay, sorry. This is going to be user input. So we are going to get the user input. And finally, what we have to do is, using the model, we are going to predict this input. We're going to predict the user input. Okay. And let's say we are going to call it as predicted price. Okay. And what we can do is, finally, we can print, let's say, predicted price of the house is, and you can actually get the predicted price. And from the index number of 0, it's going to be an array. When model.predict will function, it's going to return you an array. And you can actually fetch the value from index number 0. And you can show that the predicted price of the house is US dollar something. Okay, so we can write the code in such a way in order to make a simple command line script or an app, and then this same model can actually be used with a web application or a mobile application. And how generally it has to be done, we have actually explained it very clearly on our one-to-one course, where you can log into one-to-one. You can actually check how to deploy machine learning model on AWS and test using the command line terminal first. Then in the next session, we have taught how to integrate that machine learning model with the web application. And finally, you can design a responsive web application, integrate the machine learning model, and host it live on AWS so that the world can see your product. Okay, so this is also available on one-to-one. You all can actually practically implement it with that. And here, I'll test the script which I've coded here. So once we run that, name variable is not defined. Okay, let's just change it to variable. Somehow I have used variables there. So I'm going to enter that. So it will ask me, enter the lot size. I will say the lot size is, let's say, 2000 square yard. Then it will ask me the next question, enter how many bedrooms you want to have. So let's say I will have 3 bedrooms in my house. How many bathrooms you want? So let's say we will be having 3 bathrooms. All rooms are attached with a bathroom. It will ask how many stories you want. So let's say I would like to have a 3-story building. Okay. Then it will ask, do you want to have a driveway at your home? So we will say, yes, we want to have a driveway. So here in the driveway, there were 1 and 0 values were there. So you have to actually specify either 1 or 0. And in the UI, when you can create a web user interface, there you can have a combo box or anything like that, a select statement where yes and no can be selected by a user. And behind the scene, the values of 1 and 0 can go to the model and it can predict the actual values. Okay. So let's say, yes, it will have a driveway. Do you want to have a recreational room? I will say, no, I don't want to have a recreational room. Do you want to have a basement? No, I don't want to have a basement. Do you want to have gas hot water in your house? I will say, no, I don't want gas hot water. Do you want air conditioning? Yes, I want to have air conditioning. How many number of garage places you have? Let's say I will be having 1 garage places. And do you want the house in the preferred area of the city? I will say, yes, I want the house in the preferred area of the city. And once I press enter, it will tell me the predicted price of the house is US dollar 1,10,3301, somewhat like that. Okay. As well as you can actually convert that into an integer so as to get the exact price. So if I run that again, let's say, so I'll say yes, let's say 2500 should be the lot size, number of bedrooms 2, number of bathrooms 1, let's say number of stories 1 story, number of driveways, no, I don't want a driveway, recreational room, no, full basement, no, gas hot water, no, air conditioning, no, garage places, none, preferred area, none. Okay, so finally I get that it should be something like 30,743 USD. So you are going to get the price somewhat like that. Okay, so now we have got a generic application which is actually using machine learning in order to predict the price of the house. Okay, I hope you all can see that. So it is very simple to implement machine learning. These are the stages with which we have actually implemented. So this is the selection stage. Before the selection, it should be two more stages has to be implemented, like pre-processing and transformation, which I've already specified above, that how you can actually transform using standardization, normalization, all those techniques we have actually explained in both ways. Practically, you can code it as well as you can actually use the existing classes which are available in Python in order to transform all that. And once you are done with that, you can actually calculate the price with that specific model. Okay. And once it is ready, then you can make an application. So what is the benefit of artificial intelligence, data science, and machine learning technology? The benefit is, in this case, you can see we don't need to write any if-else logic here. Okay, that means we are not deciding on our own about, let's say, in case if I have to create a house and if I will write the conventional, if I will write the program in the conventional mode, I would have written somewhat like that. If somebody enters the value of a home from 2000 to 3000, the price should be this. If somebody enters 3000 to 4000 lot size, the price should be this. Then I should add on the prices for all other features, and finally I should calculate the price. So that is not required now. If you have the appropriate data of different houses, you can actually make a model using machine learning equations, and that model is actually the deciding factor. You don't need to write the decision logic. Using your input and using your output, machine learning can actually give you the logic automatically. It can develop the logic for you. It can develop the model using the mathematical equation, and you can use that mathematical equation if that mathematical equation is highly accurate. Okay, so and the recommended accuracy should be above 80% at least, so that the predictions which are done with that equation is accurate. Okay, I believe this is clear to all the participants. Okay, so this is how we generally implement the concepts of machine learning, and later we can actually convert them into what we can do is we can actually convert that into a web application. So I have already shared. So in tomorrow's session, what we will be doing, I'll quickly show you how complete stuff can be implemented with Dataiku as well. Okay, the step is very simple actually. Let us just complete it as well. You can go to create first model. You can go to prediction, since we have to select the variable which we have to select. So let's say I have to calculate the price. So price automatically would be a regression type because it is quantitative in nature. We'll go to export mode. You can choose the algorithms which you want to test. So in Python, as of now, we have only tested one algorithm. But in Dataiku, you have the facility to enable all the algorithms which you want to test on this data set. So this can actually help you save a lot of time and quickly test a number of equations. So you can see that we have the ordinary least square regression here, which we actually tested with Python. There is ridge regression, lasso regression, XGBoost, decision tree, support vector machine, stochastic gradient, KNN, random trees, neural network, lasso path. All these are the algorithms. Once you select the algorithm, if you want to modify any parameter with respect to any algorithm, you can actually configure those parameters on the right-hand side of this panel. And generally, when you will understand about individual all of these algorithms, you will be able to understand these parameters well. You will be able to performance tune these parameters in order to achieve the high accuracy of the model. And with this, actually, you can write programs for anything in the world. So suppose you are not, let's say if you want to make a product in healthcare, okay, and you are not a doctor, you don't understand about how the medicines work and how anything works. So what you just need to do, you need to quickly collect the data of medical. You have to put machine learning algorithms on that data, and automatically it will learn the decision logic. You don't need to be a doctor. You just need to integrate that mathematical model with the upcoming data which will be coming in. That's it. So even if you're not a healthcare specialist, you can make a healthcare product which can actually predict various things for the user. And in order to get the best equation, you can apply, turn on all the equations. And once you have selected all the equations which you want to test, you can go to the top right corner and click on train the model. So now what will happen in the training? The estimators, okay? So similarly, in the regression, what we had the slope and the intercept were the estimators. The estimator is also known as the model, which is going to be estimated, the equations. So what we will do, we will test 13 models, will be trained on 11 features. 11 features are something like bedrooms, bathrooms, and etc., as well as total 37 estimators that will be the coefficients of every individual algorithms. They will be calculated by training, and once they are calculated, you can actually perform the prediction. Okay, so it is simple. Just click here, click on train, and now what will happen? All these algorithms will start processing on the left hand. In the graph here, you can quickly see the accuracy of different algorithms. The orange represents random forest algorithm, blue represents ridge regression, and the metrics which we are actually calculating over here is R2 score. Okay, so depending on the value of R2 score, automatically the algorithms will be arranged. So as of now, while this equation has been tested, so you can see that quickly we have actually got testing of random forest, gradient boosted trees, and all other different algorithms. And we got to see that lasso regression, lasso LARS, this has achieved the highest accuracy, which is approximately 64%. Okay, so what you can do is you can actually see the regression coefficients which have been identified, the coefficient path which have been identified, okay, the partial dependence path, the subpopulation analysis, individual explanations about each and every value with respect to what has been predicted, along with the scatter plot of the performance. Okay, the plots which we have actually plotted using using Python. You can have these plots practically plotted here. Okay, then you have the metrics of each and everything, like the explained variance score is 65%, mean absolute error is 10861. Then finally the R2 score is 64.947. Okay, and in the house price prediction also, you can see that we have also calculated the R2 score here. Okay, I think we have calculated the R2 score above. So here we have also scored the R2 score, which was approximately similar. Okay, so very close to linear regression. We have got another equation, which is lasso LARS, which has been identified as the top equation at the moment, which can predict the accuracy of the house price with 64% probability. Now, since this data set suffers from multicollinearity, once we remove the multicollinearity, you can actually extend this accuracy to 97%. Okay, so this is something how we actually run the model. So here is the predicted data. I have also shown the predicted data. So here is the actual price, and finally at the end, they have actually added some more columns like the prediction values, the error which have been identified, the relative error. So you can add all these things into your data frame. Okay, so similarly, we have also added the predicted price column in the Python, and similarly the Dataiku does that for you. Finally, you can go to the charts in order to have a comparison. So what we can do is, let's say in case if we have to compare Y. So first I'm going to compare Y with the price, and I would also like to put the predicted price. Okay, so both of these values will be on the Y axis, and I can have on the X axis as lot size. Okay, so now it gives me a quick histogram that up to a range of 2000 values. The lot size, if the lot size is 2000, actual price would be approximately 45.4, and the predicted price could be approximately 49.8. For the lot size approximately 3000 size, it is very close to each other. Similarly, for 4000 square meters, for 5000 square meters, for 6000 square meters, it is very accurate, 78.8 and 78.9. Then for 7000 square meters, it has certain differences. So majorly it has close predictions for all the types of lot size, but there is difference at only 10,000 lot size values. So there might be certain influences with other factors which might be available. So that's why we are getting little less accuracy. So once we optimize the model, we can actually make this also close, that for 10,000 how it will be able to actually predict the price closely. Then what you can do is you can have that model ready. Now what can be done? So naturally you have got a logic done, and which is very close for the predictions of the price. Okay. So now if you implement machine learning in such a way, now there won't be any loss for the users. Okay. So if the users are using your website for prediction of the price in a certain area, then eventually they don't need to go out and ask with people that if the house is of this size and if it has these many rooms and these many bathrooms and this, what should be the price of that. So they should not get troubled with speaking with various property dealers and all and get confused with the prices. Okay, so that can be reduced, and a standard application can actually let them understand what could be the accurate price, and they can have a better deal. As well as sometimes people sell a product or sell a property underpriced because they are not aware about the market rate. So with respect to the trends, with respect to any other inflation happening, or with respect to any impact like COVID happening, so it might be possible that the property rates would have gone down. So the data science application with respect to the new transactions which are happening on that website, we can actually calculate that during the lockdown, what was the price over which the houses have been purchased. So automatically our system is going to be tuned. We don't need to change the logic again. So if you use machine learning, data science in your applications or in your business, then definitely you will be actually identifying the appropriate decisions which you should take up with respect to the response variables. Okay, so once you have got this, let's say we have got the lasso large regression is closely identifying it. Finally, what we can do is Dataiku gives you this opportunity that you can actually deploy this model. Okay, so for deployment of the model, you can select the data set. You can define that we are going to predict on housing data set. We can create the model. Once we create the model, now you can see that we have got the flow created in this way. So from where we have started from the housing data set, we pre-processed it, we have converted it into numbers, then we have performed training on it, and finally we have predicted, we have got a model ready. Okay. Now what you can do is you can actually click on it and perform scoring on it. Okay. So you can evaluate the model on already known data, or you can apply model on data for prediction. So let's say you can click on score, you can select the model. So this is like prediction. So we can have now any other data set if we want to use for prediction. Okay, but since we have the housing data set prepared, we are going to get the evaluated price. Okay, so let's say housing data set predicted. Okay, so this is going to be the predicted file. We are going to create the recipe. Once you create the recipe, you can run the script. Once you run the script, automatically the prediction price for the given data set will also be available. Okay, and you can again go back to the flow in order to see how that complete model looks. So now if you have to go for a presentation that I'm a data scientist, so they may ask, what would you be doing and what could be the differences if you analyze my data? So you can show that this is your data. I will be doing all this process like processing, extracting the important critical insights. I will be training the model, and then I will be scoring the model. And finally, we will be having the predicted data set. Okay. So with that prediction, you will actually get the actual responses, whatever is required. So this is the complete flow diagram of the machine learning process. Okay. And you can do it with Python programming, as well as once you know Python programming, what you can do is you can make use of tools like Dataiku. And one of the best thing is, let's say if I've gone to this prediction model, if you want to export it into Python, that can be easily done. So once I've selected that model, I can go to view original analysis. Okay. Under the view original analysis, you can see all other algorithms which have been compared. If you have to show that what all algorithms you have applied, you can have a complete table where you can see, we can actually quickly convert that with the R2 score value. Okay. So now in sequence, they will be arranged. So we can say that we have not just tested one equation, we have tested 13 equations, and over that 13 equations, we got to see that the R2 score with lasso layers, ordinary least squares regression, which we have used in our Python, as well as stochastic gradient descent, ridge L2 regression, they are the four equations which are actually able to predict the price of a house closely. And other algorithms in this case are not working well. Okay, but it might be possible with another data set, some other equations might work well. Okay, so all that thing you all have to quickly understand and use. So once you're done with that, you can actually go to the design again. You can go to the models again, and you can actually deploy this model. Okay, you can export it for production. You can convert that into a Python code, and you can deploy it wherever you want. Okay. So once we are done with the training, what we can do, we can select the algorithm. Let's say I've got lasso layers algorithm ready. You have this option deploy. Deployment we have already done. Once we deploy, we see the equation on the flow chart. And now, if you are not a Python programmer, you can actually export this analysis, which you have done in Jupyter in Dataiku. You can quickly export it into a Python code. Okay. So the Python code which you have been writing, now you can, without understanding Python, or else let's say if you don't have any experience with Python, if you are not a programmer, you can actually visualize all this thing with a user interface, and finally you can quickly export the code into Python. So you don't need to write it as well. So many times I have got this problems and issues with the researchers, and they say that we do research in machine learning, but we are not programmers. So we are unable to write our equations and test equations in Python. So what can we do? So Dataiku is a nice tool for the people, for both for the programmers. For programmers, it saves a lot of time. You can quickly test the analysis, compare with different algorithms, and quickly export it into Python and use it with your applications. As well as if you are a non-programmer, you can automatically get all the code implemented automatically, and you can perform the analysis and get the results. So how we can do it? We have got the code. You can actually go to the kernel, or else you can go to the cell. You can run all the cells. Once you run all the cells, you will get all the output. So the complete information has been implemented here. So the data set has been read, the price, lot size, bedrooms, bathrooms, followed by the data has been divided into testing and training data sets. So this is also important. You can see that using PDU, we can actually split train the data set into 80-20% ratio. Okay, so you can have 436 rows in training data and 110 rows for testing. So you can train the model with 436 rows, and then you can predict or test with 110 rows. That can be done. Then feature processing has been done, like imputing the bedrooms value, imputing the missing values with the standardization. You can also use transformation. You can also use min-max scaling. Okay, so that you can define. So since we have already defined the min-max method, so it actually checks if the rescaling method will be min-max, we'll do accordingly. Otherwise, we'll perform the standardization. So the bathrooms, bedrooms, everything will be rescaled, and then we will be having the model. So they are using the lasso large regressor. Similarly, we have used our linear regression, and now you can see that they have done fit. They have used the values of x and y. After fitting, they have actually performed prediction. After the prediction, you have got that this is the time which has been consumed, and we have got a Pearson correlation of 76, but it does not show the accuracy of the model here. Okay, so if you have to add the accuracy, what you can do is you can actually use the predicted value of the price, and you can write your own script now, and you can import R2 score and test it. As well as if you have to download this code, you can go to File, Download As, and download the Python file. So once you download it, it will be available on your local machine. So even if you are not a programmer, what you can actually do is you can do the complete testing or everything with your Dataiku, and later, once you are done with the analysis, you can quickly export the complete code into Python with the that particular analysis, everything included, and then you can use it for different purposes. Okay. So I believe now you all understand why machine learning is so popular in the industry today, because any analyst, he does not need to be a perfectionist of that business. It's always a good idea that if you have the business understanding, you will be able to process the data appropriately. But even if you are not, if you don't understand the business appropriately, even though what you can do is you can actually apply different algorithms on the data and you can see, you can minimize the error. So that is why whenever the anonymized data is given to you, you don't have to worry about anything. Okay, you just need to identify the mathematical equation and the column factor which gives you the highest accuracy. Okay, so let's say the response variable will be known to you, and using that response variable you have to apply the equations and you have to find out which equation can actually give you the best accuracy. Okay, so that's how analysis is done. So generally when you will be implementing with data sets, the data sets would be anonymized. You won't be able to read the data and records whatever is in them, but you will get to know about the independent variables, what they are, and using those variables you will get to know the response variable. Once you will start prediction for the response variable, you're going to get the accuracies, and using the accuracy, using the equation which gives you the highest accuracy, you can use that model in order to perform the prediction. Okay, so that's all for understanding of machine learning stuff. I believe you all have got this clear. If there is any query, you all can quickly ask me. R2 score, Rimi Jain is asking what is R2 score. R2 score is actually R squared value. I have discussed about R squared in my video. You can quickly watch it again and you can understand. R2 score is used to evaluate the linear regression model, and R2 score value is between 0 to 1. What generally R2 score does, it actually checks the value of predicted Y, the actual Y, and then it identifies the loss between them. Okay, so if the loss is less, that means the accuracy will be more, and the accuracy is identified with the value between 0 to 1. If the value is above 0.8, then it means the accuracy is high, and we can use that model for machine learning for integration with the website and with the web applications. Okay, so guys, I hope this is clear to everyone. If you have understood the session, if you have liked the session, hit the like button, subscribe it in case if you miss any notifications, and if you have any queries you can post it on comments. As well as I would really recommend you go to one-to-one, get your access to your account. We have actually recorded a lot of practical stuff here. All of our courses are 100% practical, so you can actually learn a lot of stuff about implementing the machine learning, then using full stack website development kind of concepts to make a website for that machine learning. Then you can use concepts of Android programming to make an app out of it. Okay, then you can ensure the security of that web application and the mobile application, so you can build up an overall product. And once you build an overall product, you get ready for the industry. And once you get ready for the industry, you get the opportunities somewhat like this. Let's say you can go to the company and become a data analyst, and there are various companies who are actually hiring for machine learning and for various other stuff. So let's see. So I'll just quickly type in here machine learning. Okay, just give me a moment. Let's say data analyst. Okay, so you can see that for machine learning, for Python, computer vision, a lot of people are hiring. Machine learning engineer at Excellent, Big Fractal, artificial intelligence at KB Solutions, Zycus for deep learning. Okay, so all these things are generally, there are a lot of positions for data scientists for different level of scope of work at the industry. So I would really recommend you all to go to our website hackweather.co.in, check the career programs, see what are the requirements. There are the set of programs allotted with each particular job. You can register for free on the website. You can explore all the courses, practically implement it. Now we have also extended the timeline of our talk to mentor from 12 p.m. to 12 a.m. to 12 p.m. in the evening, 12 p.m. in the morning to 12 p.m. 12 a.m. in the night. So you can actually have your questions there. They can respond you. So all that things are available on the on one-to-one, and you can gain a lot of information. So that's all for the day. Thank you so much for being available. And tomorrow we will be having our final session where we will have some discussions on telecom data, as well as we will be having evaluations and other stuff, so that final certifications will be allotted to all the participants. So that's all for the day. And faculty members, if you would like to say anything, please.
Thank you, sir. Thank you for the today's session. It was very much fruitful. I have listened so many things, and definitely all the participants will be benefited by the today's session. Thank you so much, sir. Thank you.
Thank you, sir.